Hello friends, my name is Mohsin Mullah and I welcome you all to this video lecture. In this video lecture, we are going to see the introduction part of the signals and systems. Previously, in some of the video lectures, I have given some prerequisites required for solving some of the numericals that we are going to encounter in this particular subject, signals and system. Mostly, we will be seeing a lot of integration to be performed on many of the you can say functions available like to calculate the power of a signal, to evaluate the energy of a signal, or while performing the Fourier transformation, Fourier series numericals, we need to solve many of the problems with the help of integration. Therefore, I have given some of the important rules and methods to evaluate integration of the various types of functions. Okay, so I have already given that, so you can watch in the previous video lectures. So now today here in this video lecture, I would like to start with the introductory part of the signals and systems. Now what is signal? So basically signal is it is a function that changes with one variable, you can say, and based on that information available in the signal, the person, or you can say different entities, will be taking the uh, different type of actions. Okay, like for an example, I can take an example of the very common you can say a game that we all understand, we can all relate to, that is a cricket. So in the game of a cricket, signals are very important. Okay, so when a bowler bowls overstep the crease to bowl the ball, at that time umpire makes a signal, so with a horizontal hand. Okay, so with that is indication that the ball is a no ball and action needs to be taken. That what action will be taken after that signal is that the bowler has to bowl one more ball to the batsman, as well as the batsman will be able to hit the ball anywhere, so without taking the risk of getting out. Okay, so that is what the action that will happen after the signal sensed given by the umpire there. Even in the same way, when the ball hits to the pads of batsman, in that case, umpire raises his finger to say that the batsman is out, and that is the indication that action has to be taken. That action is nothing but the batsman needs to go back to the pavilion. That is the fall of a wicket. So that is what you can we in a very simple way understand. Okay, so likewise I can give one more example in case of the medical diagnosis. So usually when we go to the hospital, so first thing that doctor does is he takes his stethoscope and he tries to listen to the heartbeat. So and also he asks us to take the deep breathing so that he can sense some kind of variations in that signal, and based on that signal coming from the stethoscope, the doctor will be able to make a decision whether there is a presence of any disease in the patient or there is absence of any kind of disease. So likewise that signal plays very important role there. And even same way, when we have some kind of heart related ailment, in that case we try to get the ECG. So based on that signal available in the ECG, so the doctor will be able to make a decision whether there is some kind of ailment in the heart or no. Okay, so that is what the action can be taken. So in the same way, likewise the weather forecast, when we want to go outside, so we want to make sure that whether today the weather condition outside is going to be a good one or the weather is going to be bad. So for that we need to have some kind of signal, so that signal will be given by the news channels by forecasting weather conditions for upcoming day or upcoming certain period of time, like at that in the evening there will be a rain or not. Okay, so like related to this cyclone Nisarg which recently happened, so it was clearly mentioned by the weather forecasting department that from 3 p.m. to 6 p.m. there will be you can say landing of the that Nisarga cyclone, because of which there will be heavy rainfall, as well as there will be high velocity winds flowing in that nearby areas. So that will be a kind of signal for us whether to go outside during that time or not. Okay, so that is the action that can be taken by the people after getting the signal from that weather forecast. Okay, so likewise in our you can say systems, electrical or technological systems, also the signals play a very important role, and we need to understand the various aspects of that signal. There are different types of signals available in the nature, so that also we need to consider. Okay, and also how we can manipulate that signal for achieving required task, that also we need to see. So for that we need to understand the entire, you can say, nature and various classification of signals, and also how we can use our known mathematical operations on those signals to manipulate the signal as per our requirement. Okay, so now let us begin with the basic definition of signal, that is technical definition of the signal. So basically a signal can be defined as a function that conveys certain information which depends upon one or more independent variables. Okay, so therefore I'll just try to write the definition here. Definition of the, okay, so definition. So here signal can be defined as a function that a signal can be defined as a function that conveys information, as a function that conveys certain information about some physical phenomena. Okay, mathematically uh, signal is a function of one or more independent variables. Okay, so here based on the number of independent variables that the function depends upon, so we can classify the signal into two types, that is classification of signals. So this is the basic classification based on the independent variables. It is not the actual classification. So here based on the single variable or multiple variable. Okay, so if the signal depends upon single variable, in that case it will be called as one dimensional signal. So if so I'll just try to write it down. If a signal signal depends upon a single variable, depends upon a single variable, then the signal is called one dimensional signal. And if the signal depends upon, and if the signal depends upon two or more independent variables, in that case the signal is called what it should be called is called multidimensional signal. Okay, so depending upon the number of variables, if there are two variables, it will be called as two dimensional. If there are three variables, it will be called as three dimensional signal. Suppose we can take the example here, sound wave. So now I'm speaking and you are able to hear my voice is because there is a passage of waveform through the air, and that magnitude of that waveform is changing with respect to time. Therefore, acoustic signal or sound signal is a one dimensional signal. Okay, so example of one dimensional signal is here acoustic wave, sound wave or acoustic signal. So I'll just write it as acoustic signal is one dimensional. And image that we take, photograph that you click from your mobile phone. So if you observe that photograph, so it is having two axes, one is horizontal, another one is vertical. So that will give the breadth and depth of the signal. Therefore, because of that, it is a picture is a two-dimensional signal. A picture is a two-dimensional because there are two spatial, so space related dimensions. One is horizontal, another one is vertical. So two-dimensional signal. Okay, so that is what you can understand from that. And as I told you, different examples can be considered for the signal, or the you can say the signal received by a stethoscope, that is the heart rate of the person, or else you can also try to understand that with the help of a weather forecasting signal. Okay, so now basically whatever signal we are having, so that signal will be now represented with the help of a graphical form. Okay, so basically we can have a mathematical equation, but also we can plot a graph for that particular signal. And here we are going to restrict our analysis of the signals only to single dimensional signal or one dimensional signal. Okay, so we are not going to talk about two dimensional signals over here. Okay, so basically the signal can be given in two basic forms. Okay, so that is continuous type signal and types of signals. I'll write types of signals. So in nature we get two types of signal. One is continuous type signal, another one is discrete time continuous time signal, and second one is discrete time signal. Okay, so in a continuous time signal, what would happen? So from the name itself, you can understand that the signal is continuous. That means there is no break in the signal. Suppose if you take the example of temperature. Now temperature, as you know, is changing continuously as the time is passing. So there is no break in the signal. So right from the beginning, suppose if you take one particular instant as the 0th instant, and from there onward the signal of the temperature is going to change like that. It is increasing, decreasing, it is going to stay at particular temperature as the time of the day is changing. Okay, so it is never going to get break from that. So that is the type of signal is called as a continuous signal. So in the same way we can also have a discrete time signal. So discrete time signal, basically you can practically you can understand this with the example of a you can say share market signal. So if you understand share market signal, it is a time dependent signal, so which will be given at every day at the end of the day. So that is a closing day. So at you can say 3:15 p.m. So there will be closing time for that stock market, and every day, so at 3 p.m. you will get a particular, you can say, a type of signal here every day. So the signal will be higher for a stock of a company you can take. So it will be higher or lower. So there will be opening time and there will be closing time. So at opening time it will be changing until closing time it will change, and at closing time it will stop. So from closing time till the next day's opening time, there is no availability of the signal. So here the signal is available between certain time period. So that is called as the discrete signal. So here that discrete time signal is going to be available at uniform intervals. So here, as I took the example, Okay, so sorry for the inconvenience. So the signal will be available only day after day. So there will be a gap of say 1 day. So from 3:15 p.m. to next morning 9 p.m. say around about say it will be more than 12 hours, say 15 hours for example. I'll take randomly 15 hours. Every means every signal will have a gap of 15 hours. Okay, so for that particular company, the next signal will be available only after 15 hours. So therefore, this is called as a discrete time signal. So here I have shown like in terms of the buildings or the blocks here. So sometimes this signal can be just represented in the form of a, you can say, instant. So at only one instant. So here it can also be represented just by a line indicating at that instant, and that line is representing the magnitude of the signal here. Okay, so now this type of signal you can say can be obtained from the available continuous time signal. So that is if there is suppose a continuous time signal, and that continuous time signal can be sampled. Suppose if I take the example of the temperature. Okay, so the temperature is changing like this continuously. So now I want the temperature at different instants. I do not want to see the temperature at every instant. I want to see it at particular instant. Say morning, if I said 10 a.m., I want to see at 10 a.m., 11 a.m. So likewise, I'll give 1 hour gap between each reading. So because of which what will happen, so depending upon the that particular timing, so there will be different magnitude of the temperature available. And when I'm taking that value and I'm plotting it separately, so what I understand is that I'm going to have finally only the value of the temperature available at those time instants. It will not be available continuously, but it will be available at 1 hour basis. So I will get say morning it will be somewhat 25 degrees Celsius, then it might be 26 degrees Celsius. At 12 o'clock it might be highest 28 degrees Celsius, and in the 1 o'clock it might be around about 27 degrees Celsius. Okay, again here might increase to 27.5 degrees Celsius, and at 3 o'clock 26 degrees Celsius, 4 o'clock 25 degrees Celsius, and so on. So I'll get this discrete values at discrete instant. These are not continuous values but discrete values. So whatever darkening I'm doing, so those are the only values available to me. So this can be obtained by using sampling. So here the time difference between the two consecutive instants is called as the time interval. Okay, so this is called as the time interval, and this time interval is going to remain constant. This is called as sampling time period. Time interval is nothing but the sampling time period. So you can also write this as sampling time period. So the continuous time signal can be converted into a discrete time signal by using the sampling time period here. Okay, so that is represented by tau. Okay, so this is what you can understand. And now if you want to represent the continuous time signal and the discrete time signal in terms of mathematical form, so usually the continuous time signal is represented as x of t here. Okay, and the discrete time signal is represented as x of n. Okay, so here continuous discrete time signal is called as also a sequence. Okay, so it is not usually called as a signal, but it is also called as sequence. Okay, so that signal can be sequence can also be represented if for example if I take the example of this above signal here, if I want to show this as the signal, so here you will usually use the square bracket. If you use the that circular bracket also, there is no problem, but most of the time it is preferred to be used with the square bracket as we are representing a sequence. So here the magnitude of that signal can be just substituted as the say sequence here, sequence of numbers. So here if I take the example of the temperature, so first signal is 25, then second signal is 26, then the third signal is 28, then the next signal is 27, 27.5, and so on. As many signals means values of the signal we want, we can insert here. So those signals are represented as a sequence of different magnitudes. Okay, so this is what you can say the representation of the two signals, that is the continuous time signal and the discrete time signal, and remaining part of that continuous time signal and the discrete time signal we will be discussing in more detail in the upcoming video lectures about the classification of signal, and also we are going to use a lot of numericals to understand how we can perform different operations on the continuous time signals as well as the discrete time signals. Okay, so till then, I hope you stay at home and stay safe. Till then, happy learning and thank you.